short circuit transconductance and the voltage gain calculation. So if we consider any linear network, you can always replace this network by a Norton equivalent current and in parallel with a Norton equivalent resistance. You can do the same thing with the Thevenin equivalent. Now let's focus with this Norton equivalent. So for the given linear network, you can always find what exactly the short circuit current. Okay, by shorting that output port, you can always measure. It is easy to measure. Similarly, to find out what exactly the output resistance, you can apply a small voltage or incremental voltage, and you can see what exactly the incremental current. Taking the ratio, you can see what exactly the output resistance. Now, same idea we can extend when we have input voltage as well. So here we have this linear network. We have a input voltage and the output voltage. Now, the ultimate goal is to find out the voltage gain of this linear network, and let's see how we can do that. So basically, this is the equivalent model for this linear network. You can always replace it by some, let's say we are ignoring all this input impedance or input equivalent current, just to if we just compare with that simple MOSFET. So this is equivalent to our MOSFET model. So that's why we are ignoring all these input side parameters like input resistance and input currents. Okay, because this all are input resistance is infinity, input current is 0. We can assume. So this is equivalent to our MOSFET. Now, for this network, you can also find out what exactly the short circuit current. Just you need to short the output and you see what exactly ISC. Okay. Now, you can always calculate, or the equation, you can write the equation for ISC is basically this sum GM times the input voltage, correct? And from here you can calculate the GM, capital GM, that's called the short circuit transconductance. Okay. Now, the same, just like this one, you can calculate what exactly the output resistance. So for this, whatever the input source we have, we need to replace it by equivalent model, that is a short. It's because it's a voltage source. So you can apply a small voltage Vx and calculate the current Ix, then take the ratio, you will get the output resistance R out. Okay. Now, how does it help us? This method actually helps us to calculate the voltage gain. Okay, because if you see the expression of the voltage gain from the input to output, this output voltage is basically what this current times this resistance Rn. Okay, so what is this current? This current is basically Gm times Vi, and the output resistance is basically Rn, right? So what is this Gm? This Gm is basically your short circuit transconductance, because we have already calculated here. We found a method to calculate the GM. Okay, how we can calculate? They just need to short the output, see what exactly the current, the short circuit current, and then take the ratio of this current and the input voltage. That will give you the GM. Okay, and also we saw how to calculate the output resistance. So in this expression, you know what is GM, what is Rn. Okay, then this ratio V out by Vi is basically GM Rn. GM times output resistance, basically your voltage gain from the input to output.